All right, guys, so we're going to continue on our investigation of right triangles, looking at right now just one category of special right triangles. So, these special right triangles that we're going to look at in this lesson are called 45, 45, 90 special right triangles. So, they have a relationship basically where the two leg lengths have to be the same because the base angles both have to be 45 based on the fact that the third angle is going to be 90 because it's a right triangle. So if we have an isosceles right triangle, two sides are the same, the base angles have to be the same. That's just the definition of isosceles. Then basically what we have is if the sides are going to just be some value we call them x, so both of the sides have to be x. Then to find the hypotenuse, using the Pythagorean theorem as you see here, then you can see that C is going to be that leg length, which is just we labeled as X. If it's 15, then if the leg length is 15, then it's 15 in for X. So the hypotenuse is going to be X times the square root of 2. And that's just based on the Pythagorean theorem, as you can see there. So that's just in words over there in that little bubble there. So that's labeled. So the two side links that are congruent because they're isosceles, 45, 45, 90 special right triangle, they're x, and then x times the square root of 2 is the hypotenuse every single time. So let's take a look. So on this first example, this was kind of hard. This first example, we have a special right triangle, 45, 45, 90. You can see here. So each side here has to be the same length. And we don't know that that's going to be x. Well, we know that 24 is going to be equal to x times the square root of 2. That's just set. Okay, that's just by definition and by the Pythagorean theorem. So basically, I have x times the square root of 2 is equal to 24. Well, just like any other time we have x times some number, we have to divide. We have to do the same thing here. We're going to divide each side by the square root of 2. Now, if you'll remember, you can't leave your answer like that because you cannot leave a radical sign in the denominator. So I'm going to have to multiply by the square root of 2 over the square root of 2 to simplify this. That leaves me with 24 times the square root of 2 divided by 2. Now simplifying it even further because the coefficients of 24 and 2, those can divide. Sometimes they'll just reduce, but this time that's going to divide and make a nice pretty number. So x is going to be equal to 12 times the square root of 2. And so that's what each leg length would be, 12 times the square root of 2. So I know you're thinking, whoa, but you said that the hypotenuse is going to be x times the square root of 2. Well, or the leg length, whatever the leg length is. Well, this time it's 12 times the square root of 2. If I were to multiply that by the square root of 2, it gives me 24. So we're good there. It's just kind of a little bit backwards on that one in thinking. Now, this one's a little pretty much straightforward. And so we're given a leg length. We need to find the hypotenuse. Could we use this? We could do this by the Pythagorean theorem. We know that 7 and 7 go on, but we know that this is a special right triangle, 45, 45, 90. So therefore, we know that the hypotenuse is x, which is 7, okay? X times the square root of 2. So since x is 7, it's 7 times the square root of 2, and boom, you're done. Okay, you can multiply that out if it was a decimal approximation, but on this instance, we're just going to leave it in that radical form. All right, so here we kind of are given the opposite. We know that the hypotenuse is 11 times the square root of 2, so we want to find the leg length. Well, remember that the hypotenuse, which is across from the right angle here is going to be x times the square root of 2. Well, in this sentence, instead of x, we're going to use y. So really, it's going to be y times the square root of 2, and I'm using y because that's my leg length there. And so 11, see how 11 is in place of y? Well, y is going to be 11. You can work this out the same way we worked the first one out. We know that the leg length, which is, we don't know, is going to be the hypotenuse times the square root of 2. So we're going to have 11 square root of 2 is equal to y times the square root of 2. Divide by the square root of 2 on each side. Well, that just divides out and makes 11 is equal to y. So it works out the same way, but if you're given your hypotenuse in this form, why not just use what you know about special 45, 45, 90 special right triangles to find out what that leg length is. All right, so number 4, you'll notice here does not give you a picture, so we're gonna need to draw it. So it says a square has a diagonal of 13 meters. What's the length of the square? So if you'll remember, a square has to have all of the sides have to be the same length. So we have a right triangle here because a square has 90-degree angles. And we have our special right triangle since we know that the side lengths are the same. So the hypotenuse, basically it says the diagonal is 13. Well, this one is kind of similar to the first one where we have the side length is x and the hypotenuse, which is 13, has to be equal to x times the square root of 2. It has to be equal to the side length times the square root of 2. So 13 is equal to x times the square root of 2. And since it's not in radical form like it was like in the previous example, we're going to have to divide by the square root of 2. And so 13 divided by the square root of 2 is equal to x. Remember, you can't leave it in that form. So I'm going to multiply by the square root of 2 over the square root of 2. And so I'm left with 13 times the square root of 2 over 2 is equal to x. This time, since 13 and 2 don't simplify and they don't make a nice, pretty coefficient, I'm just going to leave it as 13 times the square root of 2 divided by 2. So don't make that 6.5 and don't make that and don't try to change that or reduce that to anything. So just some things, just the kind of overall, remember that these for 45, 45, 90, the side lengths have to be the same measure. We label that as x. And then we know that the hypotenuse is going to be x times the square root of 2, or the leg length times the square root of 2. And so you can solve it backwards and forwards. You can find the leg length given the hypotenuse, and you can find the hypotenuse given the leg length using that. So now it's your turn to practice with your skill check.